This is V. Sujit Babu from ECAB section. Now, today my topic is about graphical representation of Rolle's theorem. Introduction to Rolle's theorem. Rolle's theorem is a fundamental result in calculus. It state it states that for a continuous function that is differentiable, there exists at least one point where the derivative is zero. This theorem provides a crucial connection between the geometry of curves and their slopes. ftc1 d by dx of integral 0 to x f of x dx into f of x. ftc2 integral a to b f of x dx f of b minus f of a, where f of x into f of x dx. Conditions of Rolle's theorem. The function must be continuous on a closed interval a comma b. The function must be differentiable on open interval. The function values at the endpoints must equal to, that is f of a equal to f of b. Graphical representation overview. A graphical representation helps visualize the conditions and conclusions of the theorem. It illustrates how the function behaves at the endpoints and within the interval. The graphical approach enhances understanding of critical points and their significance. Now let's understand more in detail with the example function selection. We will consider the function f of x is equals to x square minus 4x plus 3 for demonstration. The quadratic function is continuous and differentiable everywhere. The endpoints for our interval will be 1 comma 3 closed bracket 1 comma 3 as shown in figure. Graphing the function. The graph of f of x is equals to x square minus 4x plus 3 is a parabola opening upwards. Plotting the points f of 1 and f of 3 shows that both yield the same value. The graphical representation begins with a clear dissipation of the function's curve. Use the parabola tool to graph quadratic function f of x is equals to x square minus 4x plus 6. Graph the parabola by first plotting its vertex and then plotting a second point on the parabola as shown in the figure, as shown in the graph. The endpoints of the interval are marked at 1 comma f of 1 and 3 comma f of 3. Both points lie on the same horizontal level, satisfying f of a equal to f of b. The correspondence is essential for applying Rolle's theorem. Finding the derivative. Next, we calculate the derivative of f of x. The derivative f dash of x is equals to 2x minus 4 gives us the slope of the tangent at any point. Analyzing the derivative is crucial for identifying critical points. Here is the example 21. Find the derivative of the function given by f of x is equals to sin x square. So let y equal to sin x square. We need to derivative of y with respective to x. Like example, dy by dx is equals to d sin x square by dx. Cos x square into dx square by dx. Cos x square into 2x square minus 1. Cos x square into 2x into cos x square. Setting the derivative to 0. We set the derivative f dash of x is equals to 0 to find critical points. Solving the equation 2x minus 4 is equals to 0 yields x is equals to 2. The critical point is located within the open interval 1 comma 3. Evaluating the critical point at x is equals to 0, we evaluate f of 2 to find the corresponding y coordinate. The value of f of 2 is equals to 1 indicates a minimum point on the graph. This point will be essential in confirming Rolle's theorem visually. Plotting the critical graph. At x is equals to 2, we evaluate f of 2 to find the corresponding y coordinate. The value f of 2 is equal to 1 indicates a minimum point on the graph. The point will be essential in confirming Rolle's theorem visually. Plotting the critical graph. Plotting the critical point. The critical point 2, 1 is plotted on the graph of the function. The points with vertical tangents are critical points. The points lies between the two endpoints 1, 0 and 3, 0. The tangent at this crucial point has a slope of 0 indicating a horizontal line. Tangent line visualization. A horizontal tangent line at 2, 1 confirms the existence of a slope of 0. This tangent visually represents the condition given by Rolle's theorem. It emphasizes the transition of slope transition of slopes from the negative to positive around this point. Summary of finding. We have demonstrated the conditions and results of Rolle's theorem. The graphical representation clearly shows the critical point where the derivative equals 0. This visual aid enhances the comprehension of the theorem's implications. Applications of Rolle's theorem. Rolle's theorem is foundational for providing more complex theorems in calculus. It is used in optimization problems and in analyzing the behavior of functions. Understanding its graphical representation aids in real-world application. Generalization of Rolle's theorem. The mean value theorem generalizes Rolle's theorem to a non-equal endpoints. It states that there exists at least one point C in A, B where the average slope equals the instantaneous slope. The graphical representation remains the crucial for understanding this generation. Comparison with mean value theorem. The graphical representation of mean value theorem includes secant and tangent. The secant line connects endpoints while the tangent line touches the curve at point C. This comparison highlights the relationship between both terms. Common misconceptions. A common misconception is that Rhodes theorem applies to all continuous function. Remember that the differentiability is vital condition of the theorem. Visualizing the function helps clarify these distinctions. Practice problems to reinforce understanding. Consider practicing with various functions. Analyze different intervals and determine if the condition of Rolle's theorem hold. Graphical representation of this function will enhance problem solving skills. Conclusion: Rolle's theorem provides a powerful tool for understanding calculus concepts. The graphical representation elucidates the relationship between function and behavior and derivatives. It serves as a foundation for deeper exploration into calculus and its applications. Further resources for additional practice, visit calculus focused websites and textbooks. Online graphing tools can help visualize various functions and their derivatives. Engaging with their resource depends compensation of the theorem. Questions and discussions. Open the floor for any question regarding Rolle's theorem. Discuss can include the practical examples and other related theorems. Thank you.